So I suggest that we get started. Good evening, ladies and gentlemen. I'm so happy to also be able to say ladies because a lot of places where I talk, it's ladies and gentlemen, and then I find out there are no ladies in the room. So welcome to Vienna. I have the honor to start the forum. For people that don't know me, I'm Jochem Herman. I'm chief scientist and co-founder of the Dutch company Adimec. We make cameras, by the way. But I'm standing here in my position as president of the European Machine Vision Association. EMVA has more than 100 members, mostly companies active in machine vision. And on behalf of the board of the EMVA, I really welcome you to the second European Machine Vision Forum that we have now in Vienna. Of course, I don't have to tell you what machine vision is, and I don't have to tell you how fast the developments are in machine vision. And that's interesting because when I started 33 years ago in machine vision and more in factory automation, it was already a fast evolving technology field. And that's 33 years later still the case. Interesting, but I think these things are moving at a much higher pace than it used to do 30 years ago, say. Of course, a lot of innovation, a lot of research needed for that. And then you see the problem that the companies that are typically in machine vision are a lot of SMEs. They don't have really research. But they have a need for the results coming from research. On the other side, there are the research university research institutes that have an interest in meeting with the industry. So that's what the European Machine Vision Forum is all about, bringing together industry and research and try to spend a day or two and have meaningful talks, posters, networking. And of course, the concept was already there for 25 years in Heidelberg, started by Bernd Jehne. But that was only for the German-speaking Europeans, so to say. And I'm so happy that last year we have had the first European Machine Vision Forum in Heidelberg, where it all started, of course, the birthplace of the concept. And there we already had a very good first forum, I must say. With a lot of good talks, with a lot of good papers, with a lot of networking, enthusiastic people in the room. And I'm happy to see that, again, we are with so many for the second forum. Well, based on the feedback we learn every year, based on the feedback from last year, they said, okay, 2 times a half day for people that travel this far. Perhaps we should make it a little bit longer, so that's why we added. We started now on Monday on the Wednesday evening, so we can start on Thursday morning early, and we have an extra half day, and also time for the discussion that we will start, but also we have some time for networking tonight, so that's good. And I'm sure that next year we will have a slightly different format because we have an active group of people that are talking and thinking with Bernd, how can we improve the event further? So let's get started. I wish you all an interesting and nice stay in Vienna. Interesting talks, get to learn what the others are doing, get to know people. That's great. And I would like to invite Bernd Jehne for his introduction and to get started with the forum. Bernd?
Yeah, thank you very much, Jochem, for this nice introduction. And Jochem told us it is really about networking, and so we thought to break the ice and really to get the discussion going on what is the best what we could do on the first evening. And this is a discussion with a podium with several members, but not only with the invited members here of the podium, but also with all of you. I will explain in a moment how this is going to take place. But first, I would like to ask all the members of the podium to come forward. Here we have for everybody a chair. I will take this one here. You can sit wherever you would like. No problem. So just for techniques, there are 2 other micros available, and if you speak, just catch one of it. Well, you have seen, or you see it already up here, that the focal topic of this year's forum is next generation vision systems. And you all know that a system is much more as its components. And especially for vision systems, we have a lot of different components, and this makes the whole thing so complex. So we have illumination, we have optics, we have image sensors, we have hardware platforms, we have algorithms, and we finally, of course, have to integrate this system and adapt it to the needs of the market. So a lot of very different aspects of system. And well, if you look how all the people who come into this field are educated, you find out, well, there is a computer scientist who knows about algorithms, there's the optics guy who knows about optics. But you all know it's absolutely not sufficient if you want to have an optimum solution just to optimize the individual component, or just take care of one component and think then the problem is solved. And this is a little bit what we would like to discuss here, and we would also like to set the stage with this discussion for all the discussions we have in the next 1.5 days. And this is why actually we structured the podium discussion according to the 3 main topics. One is, I make it very short now, image acquisition. It's platforms and integration, the second one. And the third one is algorithms and learning. What we will do is we will discuss each of these topic now. We have about 20 minutes for each of this topic. And we will first start the discussion here on the podium. And then you can join in at the end. So each of these sections, so we would like to spend not more than 15 minutes here on the podium, so that at least 5 minutes are left here for you. And of course, this should just trigger what's going on tomorrow and on Friday, so that you can just continue this type of discussion. Well, but the first what you would like to know, of course, is who is sitting here. And as I said, vision systems have so many components, and we have, of course, research and industry, and so we try to select here the podium that all the important aspects are really covered. And I think the easiest is we start with Jochen here. He has already introduced himself. Maybe he wants to say one or the other word concerning. So 1 minute, not longer, please.
Okay, I will not repeat what I did, but in ADIMEC as chief scientist, I am now involved in the core technologies. Of course, imaging is sensors is an important one, but also processing. And what I'm involved is well, planning on the longer term. So what are the strategic directions for ADIMEC? What are the partnerships that we developed and so on?
Thank you.
I continue. My name is Wolfgang Eckstein from MBTech. I'm in the machine vision business for a couple of years. I started in the 80s to do that. And I started with software, and still we do software. I had been at the university for 12 years, so doing research in this field. And 20 years ago, we started the company, MBTech, and still I'm happy to work in this field.
Hello, good evening. My name is Horst Bischoff, coming from Graz University of Technology. So I'm more on the science side. I just calculated what you said before. So I'm doing now computer vision since 28 years, so not as long, but almost.
So we have some veterans here.
And which is sort of nice, and I keep telling my students, when I started working in computer vision, it was sort of an obscure field in computer science, sort of on the border. Now it's in the center of computer science, which makes it very exciting. So I'm leading an institute at Graz, about 80 people, not only doing vision, but also graphics. I have now another job at the moment, which is Vice Rector Research for Holteo Graz, which consumes more time than I wish, but still doing some vision besides that.
Well, good evening, ladies and gentlemen, and it's an extraordinary pleasure for me to be here, as I'm probably the only one in this room who doesn't have much clue about vision. My background is with PLC business. I'm with company B&R. My name is Stefan Schönecker, and I'm representing here actually the voice of our customers in the field of factory automation, and more specifically machine builders. And I would like to contribute and share with you and with the room why a very large part of our customers really eagerly is looking for machine vision, but literally none of them has succeeded so far.
Hello, good evening. My name is Andreas Farabel, and I'm the head of the Center for Vision Automation and Control at the AIT. So personally, I'm in the business of image processing about 30 years, so similar to the others. And this center has been founded beginning of this year. And as the name says, already we are dealing with vision, but not only vision to make image processing, but also we want to make automation based on this vision and controlling of the system based on this vision. So we think that this should cover the whole aspect that's possible with vision and that's needed for nowadays automation in the industry. The AIT is something like industry, like the bridge between research and the industry. So we are not a university, we are a research institute, and we take all the students from the university and we try with them to provide the knowledge and the information what they have learned on the university, what they have researched there, to bring this to the industry. And that's our goal.
Good evening, ladies and gentlemen. My name is Jürgen Bayer. I'm the head of the Fraunhofer Institute of Optronics, System Technologies and Image Exploitation, and also I'm a professor for computer science at the KIT, Karlsruhe Institute of Technology. My research fields are automated visual inspection, image processing, pattern recognition, machine learning, and Industry 4.0. And before my academic career, I was 20 years ago in industry for 5 years and established at that time a small company concerned with image processing and robotics in foundries. At that time, I earned my money with designing vision systems, and for me, it's a passion, this topic up to now, and I'm very eager to hear what we are discussing about.
Yeah, my name is Dietmar Ley. I'm a board member of Basler. We are one of the few northern German vision companies. So we are also in the camera business, like Adimec is. I discovered that I'm also 30 years now in vision. So also one of these dinosaurs here. The reason why I'm here today is I was very excited when Bernd opened up or described the topic that he wanted to discuss during that forum. Because looking back over these 30 years, I mean, there has obviously been change all the time. Jochen, you mentioned it. On the other end, I perceive that the last, say, 15 years have, from a technology point of view, been rather stable. I mean, I would describe this as the age of the PC vision. And what we see right now, and we are investing quite a few resources into this, let's say, upcoming new technology of embedded vision, because we feel that we are at the verge of transforming from these old PC vision days into a new era. And we feel that this is a very interesting point in time, and that this is, let's say, opening up a lot of new opportunities for the industry. that we can eventually move out of the factory space into other very interesting, appealing new spaces. And when I heard that we are talking about new platforms, I was really excited and right away said, okay, I'm coming. And this is why I'm very excited to join this podium discussion.
Okay, thank you very much. So I hope that you got a feeling that we have hopefully the right mix here. Industry, research, and all the different topics. Also applied research here, 2 times applied research. So let's get started. The first big focal topic of this forum is everything what has to do with image acquisition and also new modalities which are popping up, for instance, hyperspectral, time of flight and all these things. So let me ask the first question. Actually, the first component you might think about is the image sensor. We have not really an image sensor expert here now. We will have one tomorrow. I don't know whether he's already here, Albert Teubesen. He will talk tomorrow about the really exciting advances with image sensors. So I would like to ask this question both to Jochen and to Mr. Lai. You, as a camera manufacturer, what actually would you expect, or what would be the improvements in image sensors which would help the industry most? Are there new solutions on the horizon, what you see, or are you working on that? So the question more, what would be for you the ideal image sensor?
Okay, the ideal image sensor. That's a nice one. I think everybody knows that image sensors are difficult, very expensive devices, and we are currently benefiting, and it's also embedded. We are currently benefiting from the fact that these technologies end up in consumer electronics. And all of a sudden R&D money is spent there, and as a machine vision industry, we get some great devices coming from there. If you look at silicon, it's about more pixels, more sensitive, higher speeds, whatever. I think what is very important is now the step to go to lower power. One of the things is to make things smaller and more affordable, to have vision basically everywhere, not only in your phone, but also in every place in a machine, for example, or at the doctor's place. It has to be more affordable, it has to be smaller. And I think there are currently quite some trends in the sensor that's supporting that. Looking at smaller pixels, good pixels, but also looking at image stacking, that you are having several layers of silicon or other focal plane array materials like InGaAs, where you can have different wavelengths, more information available, and also do some processing on the chip to reduce the amount of data, for example. I think these are that kind of solutions. The problem is it has to come from the consumer market, because otherwise nobody's going to pay the bill of the fabs and the developments. But there are quite some things being done there that I think that we will benefit a lot from on the sensor side. And together with the embedded trend in general, it will allow us to have much more capable hardware, and more capable meaning smaller, lower power, faster. So I think we are really at a point where there is I agree with Dietmar Lai on that we really see a change in industry at the moment.
Yeah, when I talked to our chief scientist yesterday about the topic, he said to me in a very provocative way, in a way, we have great sensors now, so there's not much more to expect. So if we look at the Sony IMX, they're just great sensors. So what should be done beyond that in terms of signal to noise and such? So in a way, the sensor business has become more mature. I mean, we see gradual increase in spatial resolution, temporal resolution. So, but this I consider to be more incremental. So where we expect some more groundbreaking innovation is in time measurement. For example, if we think about 3D measurement, time of flight sensors, we think that is a very exciting application space. And in order to really leverage the opportunity there, I guess we would need to be enabled to measure time more precisely with a higher resolution. So that would be something that we would really appreciate if that would be developed over time. And then, as you said, Jochen, smaller, more affordable, in order to open up these low-cost, large-volume opportunities that we cannot crack right now. Yeah.
Maybe I add something to that. I see really a trend, and you spoke about it. You have the sensors, you get now the processing directly on the sensor. We talk about computational cameras, which is sort of not only the sensor delivers an image and then you get out something of that, but you no longer can distinguish between what is done on the sensor and the processing afterwards that delivers you the signal. And there are many opportunities that come along, starting with super resolution type things or interpolating certain things there. And I think this is a big trend. I see another trend coming up concerning time, where you see these event cameras now slowly sort of delivering images that are starting to get useful. And you looking at these event cameras, you need some processing after that in order to make use of that. But it's sort of more and more integrated, and I see the trend that it will continue like that. And I think all these computational cameras, I think that this is sort of will drive us a long way more and more integrated. I see another trend that the devices will come cheaper thanks to consumers. So we will use more and more of these devices for achieving something, not like bigger chips, but using more chips in a distributed manner. And then, of course, again, the processing plays a vital role. So I think these are some trends that I see coming up.
At that point, let me mention also a very interesting sensor principle for sensors of the future, which could be very interesting, and we are experimenting in our labs at the moment. This is ghost imaging. Ghost imaging uses entangled photon pairs with different wavelengths. They are generated by a laser within a nonlinear crystal. Entangled photons with different wavelengths are generated, and then you can use one photon for probing and one photon for sensing. And for sensing, you use a photon which you can sense with silicium. And on the other hand, the photon probing can be in the terahertz domain, in the X-ray domain, in the UV domain. It's a very interesting technology, or a very interesting field for future sensors. And I think it's very promising to go in this direction.
Okay, I have some requests for future sensors that I want to say. And for example, yes, it's nice to have an RGB camera, but I think it would be much nicer to have a real wide spectral range from RGB, from visible to near infrared up to far infrared. Of course, you have different cameras actually, but you have to combine this, then you have to calibrate this, and that's quite difficult. So one wish I would have for the future is to have a camera with a larger spectral range. And another thing for the sensors is it should be possible to use them more flexible, not just getting an image one after another. Because I think that, especially in the case of computational imaging, light field approaches and things like that, you have to have direct access to the sensor, and you have to have the possibility to use these sensors in different ways, in just creative ways, not as now as you'd say, okay, you have a time frame and you get one image. For example, different resolutions for different areas of the image, and things like that.
Yeah, any other comment to this subject? There were a lot of activities going on, and I realized that obviously new modalities either being adding depth or a distance with time of flight or extending the spectral range, or even having very new things with computational imaging, because with computational imaging there's one important issue going on. You no longer try for an optimum image at the image plane, but just by a clever combination of optics, illumination, sensor itself, only in the combination you overcome traditional limits. For instance, one important example where a lot of solutions have already been provided is extended depth of field. It looks like a very stupid thing, but in practical applications, if you do not have the enough depth of field, you just cannot do the application, and just you have no more light, for instance, then you cannot close the aperture. And so exciting things will obviously come in this direction. And let me just go down to here. So maybe let me ask you, you said, well, vision does not solve all your problems at the moment. If you follow now this discussion, what do you think from the application side would be the most important of all what has been discussed here, or is there even something missing?
Well, the question is now: are we away from the sensors? Because my overall answer would be the limits, especially in the market of volume machine builders, is not with the sensors. Clearly, that there will be applications where new kind of sensors will be required. There is a lot of demand in 3D applications, 3D robot guidance, where probably, let's say, newer generation of sensors will help and could help. I could assume there could be also a need for new sensors when thinking about applications where the actual supplier of the vision system, in our case, it would be the machine builder, shipping a production machine to the end user with an inbuilt in-process vision system, and not knowing about the environment at the place where the vision system is used. So you are delivering your system to a place you have no idea about the brightness, you have no idea about the illumination system there, which again could be a factor of let's say, new generation sensors, which can help there for auto-tuning functions and all that. So that's with respect to sensors, but overall, sensors are clearly not the limit today of really significantly increase the amount of vision systems used. The limit, to put it shortly, is usability. Mm-hmm. That's 90%, and 10% is potentially speed. A machine builder, a production machine of, for example, consumer packaged goods is producing in the range of, could be, or is usually always above 10, is quite often above 100, and is sometimes reaching 1,000 final products per second, which gives the entire vision system a fragment of or a millisecond or a little bit more, and including the evaluation of the image, including forwarding the result to a robot or another system to do what's necessary to cope with the result. So speed and usability are the two most limiting factors we hear.
Yeah, very interesting that you also illuminate that from the market side. Let me put the final question I have for this topic. Vision systems, of course, have also to compete with other technology. So what is your feeling? Are vision systems gaining relative to other technology? For instance, I mentioned LiDAR, or I mentioned acoustic techniques or radar techniques or whatsoever. Are they gaining? Are they losing? Or is everything getting forward, so making progress in the equal way? That might be also important for the question of which markets actually vision might be of interest.
Well, if you just look at the sheer amount of cameras that are installed, of course it's gaining, but this is probably most of these cameras are mobile phones there. But I think vision systems are in a sense gaining because they're also a cheap sensor now. They used to be very expensive, but since this is now entering a mass market, it's becoming cheaper than radar and LiDAR especially. I see as one of the, so if you look at what are the main drivers for installing vision systems, it's clear phones is still sort of the thing, but also like autonomous driving, robots, and I think that this is a big driver. There it's clear that you cannot solve all tasks with vision systems because, you know, you have fog, you have things, and you still want to drive, so you need other sensors. So I see another big trend in integrating vision systems with other sensors. But I think a big advantage of vision systems is they're becoming cheaper and can deliver more information. You can answer more questions with vision than you could answer with a LiDAR or radar and things. So it's a sort of a more universal sensor, which gives it a competitive edge compared to other things. This would be my take on that.
I don't see the competition between the technologies. It's a combination. It's an opportunity for clever combinations. And for example, there are sensors that deliver information that image sensors can never deliver, and the combination. We have all the sensors on our disposal, and why should we have restrict on image sensors? The combination is it. Right sensor on the right place.
Okay, I think that is, oh no, you have another comment.
If it's okay, I have last comment on the point you had discussed beforehand. You were asking about new sensors. And it's interesting to see we need new sensors, but as your introductory point was, we have to make it a running system at the end. And I want to mention the multispectral sensors in this context. Everybody was amazed to see that. We have new chips, so everybody's making new cameras based on that. And then the customers want to start using them. But then the question arises, how do I calibrate my light? How do I calibrate the sensor? How do I switch between one vendor and the other? Do I actually need multispectral, or would be an analog filter quite sufficient? How do I deal with a huge amount of data? And it was interesting to see the conference OCM at the KIT in March. There were lots of reports on how scientists solved multispectral applications, and they had been working 1, 2, 3 years on these applications, and many of them had not even finished their task. And we expect engineers in the production line to use these sensors as they are and make applications. It's not working yet. So we need more than sensors. We have to integrate them. The standards have to support them, and calibration data has to go with the systems and so on. We need more than sensors.
Yeah, that's again this important integrative element. And I think it's a good point where to stop and to ask you now for either a question here to whomever you would like to address a question, or also to make a specific comment, whatever you want. So let's give it a try, at least. I know the first question or first comment is always the most difficult, but you know there are really no dumb questions. Yes, please. Let me just give you the phone, then it's a little bit easier.
Hi, my name is Pajtoš from JI. My question is to the camera manufacturers here. Talking about image sensors, and also the colleague here spoke about the issue of speeds in automation and machine vision. How do you see the future of line scan sensors? Do you also see a similar trend, like you just spoke about, onboard processing, combination of different spectral sensors? Or do you see any other trend? Because what we see in the industry is a consolidation of big players. And in that situation, how do you see the growth of the development for the line scan?
Yeah, maybe, Jochen, I start with that because we are also in the line scan camera business for quite some time. So I guess overall, for Basler, the line scan camera market in comparison to the area scan camera market has become less attractive over the last years on a continuous base. What does that mean? Has it shrunken? No, it grew, but the area scan applications grew way faster, way faster. So therefore, from a commercial attractiveness point of view, I guess the line scan camera segment has become less attractive for us. What we also see is, also again back to the ease of use aspect that was mentioned earlier here, that the systems integration companies or the OEMs without a particular vision department, let's say, have bigger challenges working with line scan cameras because the image acquisition is not as easy as with an area scan camera. So as sensors grow in spatial resolution, as they grow in data rate, many customers have turned towards area scan sensors over time. So, which has led us to believe that the, let's say, the future of the line scan camera market is certainly also, it will remain a growth market, but we think that the growth rates will be a lot smaller than in the area scan sector.
Yeah, perhaps I can add to that. And Adimec is not making line scan cameras. It's interesting, although we think that we know a bit about them. I fully agree with you. We also have customers that say, I need it, and then they find out that next generation of area scan camera that has sufficient speed is easier to integrate and fits better with the algorithms and the way how they measure. So on the other hand, I think there is one thing that you see now in the sensors, that the combination of a CCD and a CMOS sensor that like you have in the TDI sensors makes it possible now today to have very fast and lower power line scan sensors that are more sensitive than the old ones like the CCDs were. So I think technology-wise there is there's some innovation going on that is and there are some applications where line scans are a very good fit. But I fully agree. If you look at it in volume, it's a tiny, very niche market. Yeah.
I would like to add something.
Yeah.
I understand that line scan cameras are a niche market, and the development for such a niche market is quite expensive. So from my point of view, the future would be to have an area scan sensor that is so flexible that I can use it also as a line scan camera. So I can have the benefit of the big speed in the development of area scan sensors also for the line scan sensors. That's, I think, the way for the future.
Yeah, thank you. There was another question. The micro will come to you. Just please wait until you pose your question.
Hi, I'm Chris Sillip with Zeiss. I fully agree that duality is important. From the numbers that you've looked at, do you think the usability plays into the factor of the amount of cameras that you sell as an area scan because they're usable by the end user, and that if the application was, if they were trained for the application or had the tools of usability, that this may increase the sale of line scan cameras or increase the use of line scan technology?
Well, I'm hoping that I'm not making a too strong statement. There is also a gentleman from Teledyne DALSA here in the audience, so maybe he wants to comment on this as well, because he might have a better, let's say, insight into this market. I mean, let me take a commercial look at the two sensor categories. So if I'm looking at, let's say, the cost involved in the illumination, in the optics, in the integration, then I go for line scan cameras when I cannot get the job done with area scan cameras. This is the bottom line. So that means, like it or not, but every customer we have would like to work first with an area scan cameras, just because of the ease of use, because the image is right there and can be analyzed without any special image acquisition, pre-processing, shading correction, whatever might be needed. So it's just the ease of use aspect that lets the customers, let's say, prefer the area scan image acquisition over the line scan acquisition. But there are certain niche applications where it simply doesn't work, so you need it, and then you take, you kind of you take the pain. Yeah, you accept it. Yeah. So.
Yeah, thank you.
Blunt statement.
Any other? Yeah, here is another comment. Just wait for the micro, please.
Thank you, ladies last. I'm Giovanna Sansoni from the University of Brescia in Italy. My question is for the youngest man. Very young. I have been working for 30 years as well in the vision area. My question is, do you think that usability is related also to the level of knowledge of final users?
Yes, of course. It's always relative to each other. So if there would be more knowledge, the ease of use would not be such an issue. But the reality of especially focusing on machine builders is that within a big team of mechanical engineers, even in the time of Industry 4.0 and IoT and everything, there is still lots of mechanical engineers. And within them, 1 or 2 electricians would hide. And those 1 or 2 electricians do the robots, do the motion control, do the PLC control, and Friday afternoon they would find time for vision. So if you get the vision in a way that Friday afternoon, 4 o'clock, they get the vision done, they integrate your cameras. If not, they don't put a camera.
So I think that also the preparation, the education aspect is of importance. You can have the most beautiful and efficient sensor, but the end user, if he's not aware of what he has in hands and he has not time and so on, it's completely useless.
Let me add something here. It's always, as I said, the more education, the less need is on the usability side. That's clear. But think about the Friday afternoon. So. So we need a special course at your university where these electricians spend one of their Friday afternoons, 1 per year, to get a training on vision.
Not in
But that's the point. The point we have.
Driving for 8 hours to come here, so.
Mr. Eckstein has a comment.
I would even put this a little stronger. Even if there's knowledge about using machine vision, it's the question if you want to invest the money to do that. You know how to do it, but you don't have the time, meaning the money to do it. So it has to be easier.
Well, and I think now the time is right because using vision in application, it has always been a task by specialists. You know, you had a special trained people setting up the vision system, do all the illumination, do all the calibration, whatever. But I think now it's the time we have these fantastic sensors, we have excess processing capabilities. So we can now start thinking, making integrated sensor that deliver just the measurement that is needed, like counting objects, delivering speed, whatever, because this is what is then finally needed in an industrial environment. Nobody cares about the images. So actually, the things must come to a place where, you know, you don't care if it's an image or whatever. At the end, the measurement comes out that is then used by the robot for picking or whatever the task is. I think this is the way to go. And of course, this is the task of the guy who builds the vision system to understand what's behind. But this is the future, to integrate it as any other sensor.
Maybe to also make another comment. So 10 years ago, a typical vision engineer was willing to spend maybe a week to get a camera up and running together with a frame grabber. Today, if you can't get the job done within a day, the camera gets returned. So simply the tolerance versus complexity has gone significantly down. It's also maybe a matter of generation. The young people are simply used to these easy to operate mobile devices, and they can't stand these difficulty anymore. So that's one aspect. The younger the customers get, the less tolerant they are versus complexity. So then another trend we see is the trend towards Asia. I mean, we sell most of our products to Asia. It's heavily project related. And these machine builders, believe it or not, they have just 10 weeks to build a couple hundred machines. New machines. So that means that the time to market is simply a fraction of what it was a couple of years ago. So they simply don't have the time to do that anymore. So these two.
Okay, well, there another question? Yes, please.
So, Yang Li from NIT. We talk about the useness of camera. So just thinking that the image can provide very, very rich information compared to a physical sensor like a LiDAR, etc. But when you make the camera, so that it's very complicated. You try to encapsulate all the complexity inside the camera. So that means the function is normally well chosen for some applications. So in this case, a lot of potential of image sensor or a lot of information from the image will not be accessible to end user. So, I mean, from an architectural point of view, do you see any new development, new trend to make the camera? Because today you look at the camera, the architecture are almost all the same. So you have the sensor, you have some early processing, denoising, and then you pipe just the data channel to get the image to a computer. Okay, so by encapsulating all this, the user will lose all the flexibility with this kind of camera. So build a camera from sensor takes time. So if you want to innovate in a new application, a new information sensing, and that is a problem. So do you see any change in the camera architecture? So it could be universal, but also give the possibility that the end user can extract the informations, a new kind of informations in his application. So that is my question. So do you see any new development in the camera architecture?
Yeah, anybody who wants to answer that?
I can give it a try. I recognize what you say. I think that if you look at the trend that we see today, like Dietmar Lai said, the sensors are more or less perfect. The camera means that, well, the camera can be a printed circuit board with a sensor and some kind of very simple interface. That's it. That's your camera. Then if you look at the embedded vision platforms, I think they will make it easy to have a small processing platform, not a big dinosaur like a PC, but a very small board that can be very close to the sensor. And I think that allows to make, well, is it a smart camera then, or is it? It's difficult to say, but then you are able at least to have a few sensors directly coupled to some kind of embedded processing system and can do all the stuff there that you want. The problem there is that, yes, it can be done, but is it easy? No, it's not. You know, you need a lot of programming skills and whatever. You are basically building a complete vision system in almost very small board. So I think technically, yes, it can be done. I think it's more about how difficult it is to make use of it. That is probably keeping people away from really using this capability today.
Okay, thanks, Joram. We spent more time than initially thought, but the discussion was just very vivid, and so that's not a bad sign. Still, let's switch to platforms and integration, and maybe I ask that very pointed. Will embedded vision systems completely replace traditional systems, or how is the world going to change? So probably everybody here has an answer to this question, or some question marks.
I hope so. I think in the end, everybody will benefit from smaller, more affordable, easier to use systems. I think that was really helping the breakthrough of machine vision technology. Of course, it will start with the systems where there's larger volume and where you can have really have a need for small. We see some cameras very, very high end where the people are only looking at the highest speed, whatever, and that's probably not the area where the embedded systems go first. On the other hand, for a lot of other applications, I'm sure that the transition will go pretty fast.
Bischoff?
Well, in that area, I see as one of the major drivers is, of course, energy consumption there. So we're really looking for systems which use less and less energy, which are energy efficient, because we want to deploy them everywhere. And then energy is sometimes a problem, of course, not in a manufacturing environment, but in other environments, this is one of the drivers. So this naturally leads towards these embedded systems. I see another driver in vision. Looking at the sensor, we always, like when we increase the number of pixels, this was always quadratically increasing, because we simply have square sensors, and so this always, and the processing speed wasn't increasing that much. It was always sort of the linear whatever. You get the factor of 2 of processing power. So you were always sort of getting more pixels than you could actually use. Now we see also a trend in this embedded, like this GPU type things, this multiprocessor things that are going on there. So now you can actually consume also that pixels that you produce. So I think this is a good trend. So that we can now really make use of all the pixels we generate, and this requires embedded to some extent and away from PC type hardware. So I think these two things, energy plus processing speed, parallelism, work towards that.
Yeah, what I see is let's say, I see a carrot and a stick with the embedded vision. So the carrot is the things become much more affordable, much smaller. So vision systems can be put in many more applications, so which opens up a whole new universe of applications and ultimately business for everyone. So the stick is, you need to get into this, and you need to do this not too late, because this technology is not going to be emerging in the machine vision space. It's going to be developed in the consumer space. And if it's ready, then it will come as a wave. So that means if we wait too long because we don't hear much about it, because it's maybe too complex to use it, let's not misread the situation. The things are being worked on by very large companies for very high volume applications, and they're gonna come. It's not the question if they come, the only question is when is the point of time that it's gonna come. And at that point of time, we should be ready. Otherwise, we are in trouble. So why is that so? We believe that an average vision system bill of material, PC-based, somewhere between 3,000 and 5,000 euros, including everything. Software license, PC, lenses, cameras, everything, cables. So we believe that this can be brought down to maybe a few hundred euros in the future. The technology on the processor side is already there. The only thing is that people don't know how to do it. It's too complex right now. So that means once enough people know how to do it and your competitor comes up with a solution that is at the fraction of the price what the state of the art is, then you're in trouble. And that's gonna happen. Someone's gonna do it. In doubt, the Chinese or the Koreans they're gonna do it. So that means we should make sure that we don't miss the train. And should work on, let's say, understanding how these, you were talking about the systems integration, and right now it's really a pain to integrate these things because it's not the usual tool chain, and many things are not very well documented, and you have problems to get all the information from the processor makers and so forth. But it still should not hinder us from trying to get ourselves into this stuff in order to understand it, in order to make sure that we are not too late once this transition is in full swing. So will the machine vision market continue to exist? Yes, it will, sure. But the average sales price per vision system is going to come down drastically. And for the systems integrator that has only access to a regional market, say the German or the Austrian or whatever market, is not going to sell 10 times more units into the same territory when the price is coming down by the same magnitude. So that's going to be a problem. So we need to get ourselves into this technology. We need to make sure that we find new applications early on. Otherwise, we might be in trouble if we aim for growth.
Is it okay? Let me add or put it in another way. We are discussing if embedded replaces the PC. I would phrase the question differently. We are talking about a new market. We are not thinking about should I use a PC or an embedded platform. We go from the factory floor to end customers. We go from a volume of, let's say, 100% to 10,000%. We go from high price to low price. We go from flexible systems to dedicated systems. We go from distribution via distributors to Amazon selling the devices. Everything changes when we talk about embedded. It's not just PC or not. The question is much, much bigger.
Yes, I agree to both of you. What I have seen when I'm talking with the end users, and maybe this is a question also to you, the end users, they are used to PCs. They have seen the PC is there for 20 years, and they're thinking the PC will be there for the next 20 years again. And it's a standard, and I can remove one and take the next one, and it will be running the system. And the world of the embedded technology is not so straight. There are many different technologies. There are not so many standards. And the question is, how can I convince the final user that he also takes this new technology? I know the price is one aspect.
Well, I think that the price is always a question of what it delivers. So it's the value and competition that determines the price, and not if they want it or not. And I would say the market we are in, everyone is waiting for embedded vision. It's a high volume market. So no one would speak about 10 cameras or 50. So it's always hundreds plus per year with many years view on that. So it's a volume market. Therefore, also competition is high. Maybe one more comment also to the question embedded or not. The question is even what is embedded and what is PC. That's a gray zone, and there is everything in between. And I would like to maybe emphasize what you have said from one example we had in our industry. So there was a time not so long ago when there was a production machine had a PLC doing PLC stuff, and there was a motion controller running drives, and there was a robot controller running a robot, and there was an HMI control, maybe Windows-based, and a PC running an HMI. Within 15 years, there is no more new application that has more than one tiny embedded thing. Some people call it a PLC because it looks like a PLC, because the housing is a PLC. Inside, it's the same electronic you put inside a smartphone. You call it a PLC, and you put software on top. And then you make it a PLC, you make it a robot, you make it an HMI, you make it a CNC, and they expect it to be a vision system. And even more so, they expect it to be everything at once, at the same time, in a same tiny embedded form factor, and doing what it does, including, there's even in factory automation, a big demand for low power activities. There's a lot of things ongoing, decentralization, modularization, machine-mounted equipment. So putting, again, this embedded little electronic motor-mounted, and if it produces more than 3, 4, 5 watt, it will simply burn because it gets too hot.
Another remark on people are not used to using embedded, which is not true. Every one of us carries an embedded vision system with us. So I think this is how we should think.
Yeah, but the difference is you can afford millions and millions of R&D effort to develop such a phone that is made in millions of units a year. But if you're developing a dedicated machine that only goes in dozens of pieces a year, then the question is, how do you amortize the R&D effort that it takes today to build an embedded vision system? This is what I was talking about.
Yeah. So my take on that is take this as your platform, that there will be sort of library, or there are libraries around which you can use and use this as sort of, because here you have the mass market and it will get cheaper and cheaper. Of course, if you have to do special things, then this will not work. But I think a lot of applications can be just done with the hardware you have on a phone on there.
I agree. There's another point you have to consider, that we are used to this device, but we are used to change this device every 2 years, the new generation maybe every year. And in industry, you have the machines for maybe 10 years, 15 years. So, and you have to guarantee that this device will also work after 10 and 15 years. And that's totally different to consumer market.
But that problem has been solved. So there are two ways how to solve that, and the combination makes the 20 or 30 years lifetime. First, every semiconductor, every serious semiconductor company has same architecture, same technology, but different families with different life cycles, including companies like Intel, very much known for consumer products, and nowadays assuring 15 years plus lifetime for a certain part of their families. And second, then it's a lot about life cycle management, and there's the famous term form, fit, function compatible. That's a competency that has to be built up, but that's solvable, and that does assure finally 20, 25, 30 or plus years of lifetime. But that's something we are used to, and as mentioned before, a PLC nowadays has nothing different in it than what's exactly in that smartphone, still providing 25, 30 years lifetime.
Let me put the focus, we were speaking so much about hardware and not much about algorithms. And one of the big troubles, of course, you have is if you have complex image processing algorithms which are running on one platform, how do you get them on the next? And is this a big problem? Is this an obstacle so that we do not use the full power of algorithms finally? Because you say, oh, these machines are anyway cheap, and so we don't care. So let's put the focus a little bit on software, and I look to you, of course, because you are coming from a software company. So how do we handle this? You have still PC-based systems, you have embedded vision systems. How do you see really the chance that all the progress also which is happening in the development of algorithms, so image processing gets more and more mathematically, new types of things come in constantly. How can we really put that on machines and bringing into applications?
There are various aspects in your question. The first one is how to make it running physically on different devices. Luckily, we are a company having experience for 15 years in that. So whatever device you would like to choose, take our software and run it. That's fine. But this is only the starting point. The question is it usable? We had been discussing this question quite a lot already here. And Mr. Lai, you mentioned that we have to look at our kids, how they use computers nowadays. They have a problem, they go to some web store, they download an app, they use it. They don't start programming. They have no idea about parameters. It just is expected to work. So the burden on our side is to go further on this end, because looking on the market, you see applications looking like Windows 3.11 nowadays, and you have 500 icons on top and 500 pull-down menus, and nobody knows what to use of that. And having engineers coming from universities, they don't want to use it. So we have to adapt what's going on outside this building, or what we use normally, but the transfer of putting this into our everyday work seems to be a little hard for us. So we have to change our way of thinking to make solutions, and apps specifically are a very nice idea to solve this issue. And how it's being done there is that we do not argue about the complexity of algorithms, because OCR or barcode or data code reading is really complex algorithms. But you take your smartphone and it's doing the job. And you never think about what parameters to set. Thank you very much. And the main issue here is not that the algorithm is simplified, but the task is well defined. And we have to help our customers to get well-defined tasks, and for these we have to provide solutions. And this is the way how we have to change our thinking.
I would even go a step further. We need such apps, especially in the context of Industry 4.0, if we want to realize the paradigms like Internet of Things, Internet of Services. It is necessary not only to have such apps, but also to have a description of this app, to know what they are able to do, maybe in a way that it can automatically be found, to search for it, and then to compose it in a sense of service-oriented architecture as a service, a well-described service, hopefully a formally described service, and hopefully a semantically described service. So you can find in the vast amount of algorithms the right ones that solve your problem.
Exactly. I want to emphasize this point. We already used to use standards for camera acquisition. And thanks to those who started having these kinds of standards, we need this for algorithms. We have Industry 4.0, but the systems are not compatible. They have the need to describe themselves, to tell the world, I do have these parameters, I will deliver these results. Communication, in my case, works like this. So we have to extend something like GennyCam to our devices. They have to be self-explanatory and say what they can do, and do it automatically from the outside without programming.
So maybe I add to that, and now it's the right time to do it, because we have been, as we discovered, we're all dinosaurs in computer vision. So we have been educated in squeezing out every bit and sort of doing best performance algorithms, simply because otherwise we couldn't have done the applications on the available hardware. So we were always driven by, optimizing to death. Now we have, at least in some parts, enough processing power. So we now can make a step back and say, now let's make it more useful. Even if the thing is not the optimal implementation, but it solved the task. At the end, it should solve the task. Before it was to solve the task, it was necessary to squeeze out. Now we should take a step back and go towards the usability of these algorithms. I think this is the next thing, and this is just the right time to do it, because we have now the processing power available.
Yeah, maybe let me still go back. Do you see whether there is a kind of a gap in our capabilities to produce algorithms? For instance, what I remember very well, you have a line in industry, production line, it works, but you had a lot of fine-tuning until it really works. And this is, of course, what we have to avoid in the future. There should be a lot of parameters to tune, but the algorithm should find its solution somehow automatically. And are we there, or is there still a need for research?
Well, I think, again, we have now really nice examples, at least when we have excess of data for training the algorithms, that it's now sort of self-tuning. And I think we are now slowly entering the area from engineering. So far, we have been engineering a lot of the systems and engineered to depths. tuning here and there and placing this towards learning these things. When we have excess data and we see really nice examples out there that they are much better than all these hand-designed things. People have spent, I don't know, hundreds, thousands of research years in getting detectors for certain features. Then these deep networks come, you train them, and you outperform them by a large margin. And this is now the time to think about sort of training these things, to doing this fine-tuning away from engineering, where we have been educated, towards building system and thinking about how we integrate this training. Might be via calibration, might be some other things. As long as we have enough data and certain applications we have, this will work. Question is, of course, when we come to markets where we don't have this data, this is still difficult. But I think a lot of applications will be just solved by really doing this end-to-end training, which we have now available, and we have now the algorithms there. Solves not everything, but a good part can be done now. And I think this will be now part of a standard vision system that you build your system no matter how, but then you have an end-to-end training to do all this fine-tuning at the machine. I think this is clearly coming.
Well, I would like to add one more thing. To make it the tuning more easy is a good direction. But if we speak, and we started with the discussion also Industry 4.0, Internet of Things, it gets a lot to auto-tuning and adaptive machines. So there will no one be there to set it or change a parameter. So it's really it's adapt to the environment. Let it be illumination or even the task it performs. It has to be. Maybe it gets from somewhere the information what it should do now, and that can change from the millisecond literally to the next millisecond, doing different aspects and different tasks in a different environment. The use of HEVs is incredibly fast growing, meaning even the location within a factory where the vision system is performing is changing. So again, the environment is changing constantly. And then don't forget, if it should reflect that needs for an adaptive production, it needs to interact with the rest of the automation system, with the rest of the production machine. And therefore also, you mentioned several of the standards, which meanwhile, I've joined several of those kind of discussions. I've learned what it is, but most of our customers have never heard about things like GIG, E,
just
or
want to use it,
huh? Well, they get afraid if they hear those terms.
Yeah.
They're used to different terms. They're used to dinosaur type field buses. They are used to a little bit kind of outdated type modern industrial Ethernet solutions. We get lots of them, 20 different flavors. And actually what they expect are things like OPC UA. Yeah. These are standards what are starting still, but they are known, they are expected. And everything outside frightens them.
Yeah, I fully agree to that. I think in a way the vision industry has always been a little bit navel gazing, to look at the environment from themselves. And I very much like the approach, listen to the customer. He typically doesn't want to do any vision, he just wants to get his parts produced, and so let's get the job done as easy as possible. But back to the question, I think one perspective or opportunity might be not to shoot for the high complexity, high-end applications first, but to look at those more easier, more down-to-earth applications that can be solved with the current technology very nicely. So to bridge that gap with the easy-to-use and self-learning and self-adapting functions for the easy applications first, because there is a huge market for that. Yeah. I was talking to a lady we've been working with a couple of years ago. She told me about a market outside the factory automation that may consume 6-digit numbers a year. So these markets exist, and these markets are typically not requesting the last photon in a very specific situation. So it's not necessarily that complex. So let's not fool ourselves. We can use we can develop such progress in easier applications first, learn along the way, and then go for the next higher complexity. So let's start easy. Let's start with the high volume, with the easier things, and then learn along the way. And I think we come to that machine learning in a minute, I guess. Then we will gather experience how all this works, where the pitfalls are, where we get the data sets from and such. And then then it's not that huge kind of a problem like it looks like now.
Yeah, Mr. Lai, we already are in the machine learning. We have actually merged a little bit already to the next topic because they are so closely related to each other. So, any comment concerning machine learning? Or let me say it provocative: is image processing out? Only machine learning left?
First of all, I would say that machine learning or deep learning is a kind of hype on one side. On the other side, you can do great things with it if you're knowledgeable. So to give you an example, I had been traveling last 12 months and visiting various customers, and everybody or many of them tried deep learning because they see how we could do great things with it. All of them failed. All. I hadn't had the chance to go to one customer who was able to use the available tools, take their images, and they had images, and train it, and it was working. It was not working. So yes, there's a great chance in that, but still we have to do a lot to make it usable. How to optimize hyperparameters, what kind of net to choose, what kind of pre-processing to use, and even if it's working, how do you know why it's working? If it's not working, how to know why it's not working? So there are various questions still, and I'm happy to hear that in research, these questions become more important and people think about, oh, we have to get some explanation what's going on in there. It's not that fancy for researchers. They want to get good classification results to be on the highest rank for some OCR reclassification. But what we need is to understand what's going on inside the nets and assist our customers using them.
Jochen, you had a comment directly? No, okay.
Yeah, using deep learning is at the moment a little bit like black magic. Complex networks with thousands, hundred thousands of parameters and a high variability on the architecture. And on the other hand, you always need a lot of data to learn all those parameters. And on the other hand, in industrial applications, you often have not such a comfortable situation with a lot of data, but you have a lot of knowledge, of prior knowledge, of expert knowledge. And I think it's very important to find ways, and it's also a scientifically interesting problem. How can you combine these expert knowledge, this prior knowledge about processes, about tasks, and to transform it in a way to certain architecture of such a network, and then to combine both worlds, to combine knowledge on the one hand and data, especially in situations you have not enough data.
So luckily, I'm now long enough in the field because when I started doing computer vision, I actually was doing the first wave of deep learning, and my PhD thesis was what you would now call a deep network. So these things have been around for some time. It disappeared. So it's sort of, so what you said in your reply to that, I think. Of course, deep learning isn't sort of that thing that solves everything. It's clear that there will be tasks where it's good for. At the moment, I would say, well, only where you have enough data, these are the tasks to approach. And of course, there are lots of tasks that you can use. There are others which either it's painful to collect all the data, it will cost you a fortune to do that. So it's better to engineer the algorithm. At the moment, maybe there are some things, but I don't expect, there is no free lunch, either the one way or the other. But I think what a lesson to learn there is we should think more in terms of architectures. And then when you sort of integrate, of course, doesn't make any sense to sort of use projective geometry, to train a network to learn projective geometry. This we know, we just plug it in the formulas. But still, together with some algorithms, pre-post-processing, you can still back-propagate all these things there. You have the tools there, which means you can do the fine-tuning of the algorithms, which usually an engineer did. And this will save you a lot of time and will squeeze you out the performance. I think these are some lessons we have learned. Really think end-to-end. What comes in, what goes out, and optimize the whole stage. So far, we have been in Vision optimizing individual algorithms and then putting together and hoping overall this thing is there. Now we have tools to train systems end to end. And I think this is an important lesson of this new wave of deep learning things that we have, which will lead to applications which are simply better. You will get a few % more, and this makes sometimes the difference. Of course, it will not solve everything, but useful tools like other things.
Maybe another comment from the business side. So what we observe is that there has never been so much investment into the deep learning like now. I mean, there are all these big processor companies, and they are convinced that they can sell their processors because there will be a lot of deep learning applications. So the Intels, Xilinx, Qualcomms, NVIDIAs, everyone is developing their, let's say, deep learning kind of software toolbox, which they are, let's say, where they're making significant investments. So on the Embedded World this year, I was talking to a couple of these people from these companies. So the average size of or number of people in the headquarters are 100 to 200 people working on this. Yeah. So that means there is some brute force behind it. So that means it will not be necessarily the factory automation applications that will be attacked first, but the technology will develop now as there is a lot of punch behind it. Yeah? And I think this we should also recognize. So it's not only it's a hype. Yes, it's a hype, but there's a lot of money behind it. And so they will be looking for the applications that can be done, will learn along the way, and will then, let's say, enable the usage of that technology in the kind of near future, say within the next 2 to 5 years. What we also observe, maybe you know also about this case, we were confronted with a situation where a customer in the food industry was delivering the data of these products, so carrots and other kinds of vegetable, to a Google team. So they are working together with Google. So they were ready to put a team behind this of a couple of people to do all this fine-tuning. Why? Because they want to know how to classify carrots and other vegetables. So this is their new competition. So I mean, it's not just a systems integrator right next door that you're competing with. You have maybe a company there that teams up with Google. They have an interest in getting knowledge about vegetable data, and so they just put a few €100,000 behind it, and then you suddenly have a sizable, dangerous competitor. So that's also something to look at, because that's new. Yeah.
I think this puts an important point. Why is Google behind that? Why is Facebook behind it? Simple, because they have the data, which should make us think how we sort of treat the data. So far, we have been always sort of selling the camera, the vision system. We don't care about the data. The question for us is, should we care about the data? Should we get it? Because in the future, we might build better vision systems. So when we deploy a system, we make a contract, we will use the data as Google does. You or Facebook, whenever you upload a photo, Facebook does something with it, learns from that. So we should think also our business model with the data, because this is value, because we can train our future vision systems on the data from the other customer or whatever, and improve our system. So this is another thing we should really take care of, and not say, well, we want to sell our hardware and a little bit software around, that's it. We should care about the data, because this will be the enabling thing. And there are certain applications where you simply can no longer compete, like face recognition or something like that. You simply don't have the data to train your system to be competitive. So you have to rely on that. And this shows the value of the data, and probably similar things happen. This is the only reason why Google wants to team up with these things.
I think there's a very interesting aspect with respect to data. And maybe also a way out of the need of the high amount of data needed. If you train a deep network in the early layers, edges, corners, and so on are detected. If you have the next application with other data, they are also corners, edges, and so on. And my people who use deep networks, they use pre-trained networks, which have seen a lot of edges and corners before from other data. It's not always necessary to have for certain applications a huge amount of data, because real-world images have a finite number of primitives. And if these finite number of primitives are encapsulated in these early layers of such networks, then they are equivalent to a lot of data. And I think it's also a very interesting business model for companies to deliver such pre-trained layers or bundles of layers which solve early vision problems and which are trained on real-world data in a broad sense.
One comment on that, from the commercial side, it's very popular to use these pre-trained nets, and the actual problem is it's not legal to use them commercially. So it's perfect for research. When you look more closely on the small printed things, it's not legal to use them. So when we go to industrial applications, be careful what you're using. You might end up in some trouble, specifically when you go into volume and you're successful. So we are going from research to industry to commercial side. Another comment, not related to that, but still staying with learning. I think learning still is missing one important step, and we can easily see that when we talk with kids. When you teach a kid what a dog is, you say, look, that's a dog. And you don't take the mouse, outline the dog, and then you say, that's a dog. Which means that what the kid already does beforehand is a kind of segmentation of the image, so that just mentioning the term dog identifies the real outline. So we need these edges, point, corners, but for going to real applications, we need one layer more with primitives which go more to semantics, so that at the end our customers can do more quick kind of training and easier understand what they are doing. So the kid says, this is a fox. No, this is a dog. And then they say, no, that's a fox. Or they say, that's a calf. No, that's a dog, whatsoever. So you do not want to generate so many samples. You want to do the teaching on a semantic level, and by this reducing the amount of training data needed. And this is way more natural. And this brings us back to what people nowadays are getting used to. They don't want to deal with statistics or something. Sorry for that. They want to talk about semantics. So if someone sees something in the image, and they say, this is what I see right now, then they expect that machine vision can do that. So it's no longer, well, if you want to do that, you have to do calibration, and after that you have to do sub-pixel measurement, and please take care that the camera is linear, otherwise it will be shifted by a third of a pixel in this direction. They say, I see it's wrong, or they say, I see it's good. And we have to go to this direction, and of course machine learning is very helpful in this direction, but yes, we need more from research to go from ideas to applications there.
Yeah, I think it's time, or do you have a final comment to that?
I would like to add something about the usability from the point of the end user of these networks. You said that the young generation is used to take an app and it's just working. And if it doesn't work, they take another app. Yes. That's correct, and that's the ideal situation for a neural network. But in the case of an industrial environment, you want to have control about your measurements, about your production, about the quality, about the tolerances, and so on. So I think this is another point, but we have to consider how can the operator have still the control about what's going on, because actually now it's something like a black box. It's working or not, but it's very hard to have control about this system.
Okay, but we were so vividly discussing everything here that we forget the audience, so I would... yeah, you forgot about that? Okay, good. So we have, of course, 1.5 days to continue this discussion. Actually, this podium, the intention of this podium are really to trigger what topics we are discussing here, and you will hear more and more aspects, of course, by the invited and contributed talks. But still, if you have an important comment or a question to what we discussed right now, please use the chance right now. All right, in the back.
Thank you. Hello, I'm Sami Fatala from the Opto Group. We discussed about, let's say, embedded machine learning, things getting smaller, cheaper, easier, let's say, they are or they will be. Do you think that there will be a big change in the business models? And let's say, to summarize, will some companies providing currently machines, vision machines or vision systems and so on, go more to the copy machine business model, for instance? Meaning that the money is not in selling the solution, it's about selling the service. This is the question.
Who wants?
Well, some models we see already, like with all these server-side type of applications where you have enough time where you can upload your image and get the result back. So the software as a service things we see already coming up, and this will be definitely more, probably not in the classical machine vision area, because either you don't want to send your data over the network, you don't have the time, but we see such models coming up already.
Sorry, thank you. Just to make my question more precise, once again, the copy machine, it gives the service on site. It's just that, let's say, instead of buying the copy machine, you pay per sheet printed. This would be more this kind of business model I'm talking about.
So I think the general answer is yes, there will also be business model innovation. So there will be such models like the one you have mentioned. What we also expect that the food chain in the vision industry, let's say, will be impacted by the erosion of the average sales price. Because what you see right now, I mean, we have the manufacturer, and then we have distribution channels that, let's say, are, the transmission belt into the regional markets. And because of the technical complexities that we have talked about, let's say, all these distribution companies need to operate a technical support department in order to consult the customer how to use the technology. So now imagine that the average sales price is cut in half, or only a third of what it used to be. what does that mean to the bottom line result of the distribution company? That means it will go drastically down. And as the biggest single line item in the profit and loss sheet is the personnel cost, this distribution company will have a problem to employ all their team in such a constellation. So that means they need to cut down on cost. So that means that their business model needs to change. Just reselling components or systems into a certain regional market is not going to do the job for these distribution companies anymore once this happens. So then the question is, okay, if these distribution companies, let's assume for a moment, there would be fewer of them, or for some markets they have a hard time to exist at all, what does it mean for the manufacturer then? So how does the manufacturer go to market then? So that means either you have enough volume to move that you can go direct, or you need to go online. So then the question is, how do you go online? How do you meet your customer? How do you consult your customer? How do you, let's say, do you know how the decision-making process at your customer is going to take place if there's no distribution companies around anymore? So that's going to happen. So that means that with the advent of embedded vision, with the average sales price erosion that is coming along with that, there will be also the need for new business models.
I'm not sure if I would be the right person to answer that question on the vision business, but I can give one example of the machine building business, which again is the customer of the machine vision business. And if you look on things like that bottle with water, and the bottle filling industry is a huge industry. And the machines that produce these kind of bottles, they can do 60, 70, 80, 90, or even 100,000 of these bottles per hour. And these machines are much bigger than this room, and the machines did cost several millions of euros. Nowadays, an end user or a customer of those machines would never, ever again buy a machine putting $5 million of cash on the table. They will buy a capacity of 50,000 per hour at a price of 1.2 cents per bottle. Who is in? Is in. 2 years later, the good growth of that factory, so instead of 50,000, they need 60,000 per hour. They will go to their supplier and ask for an upgrade package, download that from the web, and then this huge mechanical construction can go from 50,000 to 60,000. And the vision system has to scale with that. That's the answer.
Yeah, is there another question or comment from the audience? Well, it's already a little bit late, I know. Yeah, all are tired, or we have to really go to networking. So let's come to the final point here. I asked everybody here on the panel if they want to make one pointed final statement, if they want to trigger then our networking, which is continuing just after this panel discussion. Can we this time start with you?
Yeah, so I think that there are real interesting, exciting times ahead with a lot of change. And I'm believing in the bright side of the change, because this means a lot of new opportunities, new technologies, new business models, new kinds of markets, applications, everything. And I cannot wait to see it.
The new degrees of freedom that we get from machine learning, but also from new sensors and from the paradigms of Industry 4.0, I think will keep machine vision and image processing for a long time a tantalizing research field with a lot of interesting and promising results.
I also think that we are living in really interesting times, and there will be a lot of changes. And one of the important things is that we don't have to think only from the technical point of view. we have to think from the human point of view. The humans, the people are using these technologies, and we have to think, how can they use these technologies?
Well, I would like to once again express the view of and the voice of our customers. There's a huge interest there. There's a huge market out there in the machine building business that's waiting for you to serve them. But I think from the point of view of usability, even from what I've heard here, there is a sensibility on that, but I think it goes even much further beyond than what some of you might have in mind today. That's one aspect. And the second aspect, please try to speak and use the language in the terms of standards of that market. Otherwise, that won't fly. And would like to name one, and that's OPC UA. That's a key technology for whatever is coming with Industry 4.0 and Industrial IoT. So that's really the way forward in terms of standards and also semantic behavior and semantic descriptions.
Well, all of us say it's an exciting time. Of course, I completely agree. Why is it that exciting? Because I think we are now in an area where hardware is no longer the limitation. It's really our thinking, what we can make of that. We had, and following these things for a long time, we had sort of always good ideas, but we didn't have the means to really make it fly. Now this is gone away, so now we can really make all these vision things fly.
We started with a statement that virtually nothing changed 10, 15 years ago or since this time. Although it doesn't seem so impressive, embedded, and to mention again, deep learning will dramatically change our business, and there will be huge, huge growth. Although there will be changes, but I really look forward to see what is coming next.
Absolutely. Well, I'm last now. That's good. I think it's very interesting to hear everybody's opinion, and from a business side, from a technology side, from the software side. And I think we have to realize that no one of us alone can do this. This is a trend. It's big. It's much bigger than us all, bigger than the industry. That means that having podia to exchange information, to talk, to share results and challenges like this is really, I think of course we only play a very small role, but organizing this kind of things is very important, and so I'm happy that to see that it is really serving a purpose.
Yeah, thank you very much. That was a perfect end statement, and the purpose, of course, I had was just to trigger this kind of discussion here with this podium and use opportunity. Most of the people from the podium will still be around, at least this evening, I hope. We will have now this Fingerfoot and networking. And be aware, we have at least a dual core machine here now, because it would be little bit too narrow if only catering would be at that end. So it's also in the other end here, right at the other corner of the building. So please distribute yourselves. You have two outlets, one here and the other one right in this direction. And walk between the two locations is good. We are sitting all the time here around. Make the possibility to talk to all the people, and in that sense, enjoy the Fingerfoot and enjoy the discussions this evening. And thank you very much for all the experts we had here on the podium. For me, it was really an exciting mixture from all the different sides. So thank you very much to all of you.